supercharger. Noise and smoothness are the second pillar. Electric propulsion avoids the cyclical explosions of a piston engine that burns avgas, so most sound comes from the propeller and airflow. A certified electric trainer like the Pipistrel Velis Electro reports about 60 decibels A in training use. That is not a target for Tesla, but it proves what is achievable. Pair a high-efficiency motor with a well-tuned inverter and clean aerodynamics in the Tesla style. And the Tesla Super Electric Plane has a credible path to quieter hops that reduce fatigue for pilots and passengers. Energy infrastructure is the third pillar because it sets turnaround time and cost per hour. Supercharger VE4 in North America has been announced around 325 kilowatts and is tracking higher as deployment expands. High power sites shorten stops between legs, especially if Tesla introduces adapters and clear procedures for general aviation. Where the grid is weak, a Megapack can act as a fast buffer that dumps energy into the aircraft and then slowly recharges from the utility. Powerwall 3 can handle auxiliary loads and scale in small steps. Reference specs list 11.5 kilowatts continuous per Powerwall 3, and Megapack output at the factory level is measured in tens of gigawatt hours per year. With more than 5,000 public-use airports in the United States, sensible placement means the Tesla Super Electric Plane can turn quickly without relying only on strong grid points. A simple example makes the timing intuitive. Suppose the pack is 200 kilowatt hours and the aircraft can accept 250 kilowatts during its fast charge window. Charging from 10 to 80% is roughly 140 kilowatt hours, which would take a little over 30 minutes in ideal conditions. This is not a product promise. It illustrates how pack size and charge power set turnaround. Operating cost then follows. EV owners spend about half as much on maintenance and repairs as gas car owners over the vehicle life. There is no oil to change, no exhaust system, and fewer wear items. Bring that philosophy to the Tesla Super Electric Plane with a monitored BMS, a high-efficiency inverter, and an electric motor, and both downtime and lifetime maintenance have room to fall. Put the pieces together and the cause and effect is clear. Higher drivetrain efficiency wastes less energy, high-power charging, and on-site buffers cut ground time, and standardized modules with remote diagnostics reduce scheduled maintenance. More flight hours with fewer shop visits push total ownership costs down, and make the Tesla Super Electric Plane a practical machine rather than a paper idea. 3. What will the Super Electric Plane look like on the outside? Tesla's minimalist design language prioritizes clean surfaces and smooth airflow because skin friction accounts for a large share of cruise drag. Academic surveys in civil aviation indicate that skin friction can reach roughly half of total drag at cruise. Boeing research also emphasizes that keeping the fuselage aerodynamically clean is an effective way to cut drag. Applied to the Tesla Super Electric Plane, every seam and recess is reduced to calm the airflow, which saves battery energy and stretches useful flight time per charge. To achieve smooth surfaces with fewer joints, large panels and light materials are key. Composites can deliver double-digit weight savings in selected structural areas. Real-world tests have reported about a 17% reduction when replacing a metal skin on a flap subsystem. Composites and advanced aluminum alloys also resist fatigue and corrosion better, which lowers maintenance frequency over time. When the fuselage and wings are divided into a few large quick-release pieces, technicians can swap modules instead of working through rows of small rivets. The result is shorter downtime and lower service cost, which matches the practical goals of the Tesla Super Electric Plane. From the outer shell to exterior details, boarding is the first touchpoint on every flight. Flush door handles in the EV style cut drag and attract less dirt, while anti-slip steps inspired by Cybertruck industrial surfaces give a secure feel for middle-aged users. Safer, friendlier ingress means less effort during pre-flight, so total turnaround time drops and daily utilization rises. The Tesla Super Electric Plane benefits directly